Another part of the configuration that's going to be very important, as we've mentioned, is name resolution. It's really practically required on all TCP/IP networks, and it's technically required on an internal Windows network due to its reliance, or Active Directory's reliance on it. Name resolution is simply using user-friendly names instead of numerical IP addresses. And so you have a name resolution service like DNS that is responsible for resolving that. So when I query or try to communicate with server 1 or KBDC1, then it resolves that to the actual IP address. This is done up at the top layers of TCP/IP. It's called the application layer, meaning that before the actual data ever gets into a network packet, ever gets an address stamped on it, these names have been resolved to IP addresses. That resolution typically is going to happen with server queries, although it could also happen using local information such as cache files or even host files, LM host files. And so it enhances the user experience because it makes it a lot easier to access shared resources than if you had to remember numerical IP addresses. Technically, there's two different computer names. There's the DNS host name and the NetBIOS name. Now, the DNS host name is the one that we're predominantly going to use. It's part of a fully qualified domain name. So computer1.company.com, for instance. Company.com would be the domain name. Computer1 would be the computer name, and collectively those make up an FQDN. The NetBIOS name, on the other hand, represents a single computer or group of computers. Unlike DNS, which is in a hierarchy, the NetBIOS name is a flat namespace. It's just the name itself. It's limited to 15 characters, although there's a hidden 16th character that identifies the service. So a machine may register a NetBIOS name for its workstation service to connect to other systems, and its server service to accept connections for shared resources. NetBIOS is really a backward compatible type of name. Windows really hasn't required NetBIOS for years, but there are some applications that still do. So NetBIOS is turned on by default, but DNS is used predominantly. The names get resolved in one of two ways, or I shouldn't say one of two ways, in various ways. There is the dynamic name resolution and then the local resolution. The reason I slipped and said two ways is because 99.9% of the time, you're never going to get beyond the dynamic or the local, and you're not going to be resorting to broadcast. There's a couple other things that aren't even on the list because you almost never use them. So typically what we have is we have clients that are configured to utilize a DNS server. When a client tries to communicate with another system via name, the first thing that happens is a query goes out to the preferred DNS server. That DNS server is responsible for a domain or possibly multiple domains, and it has zones within its database that represent those domains. And so it looks for the queried item in that zone, assuming that it's, the domain name is one that it holds, okay? So if I were to query my domain controller for another host in my domain, then it would be responsible for that, and it would return the information to me, or it would say to me, that host is not found. But if I query my server for a domain that it's not responsible for, like google.com, then my server will forward the query onto internet name servers that are responsible for the google.com namespace. Okay? And so DNS is said to be a hierarchical distributed database in which each individual server is responsible for a particular domain or group of domains. I query my server. If the query is for a host within its domain, I get an answer. I query my server for a host in another domain. It forwards the query until it finds the server that's responsible for said domain and then retrieves the answer on my behalf. And that's how the vast majority of queries are going to happen. It's going to be that dynamic name resolution. Now there is the Win server name resolution, which is the dynamic resolution for NetBIOS names. It functions differently. It still is technically a possible feature that can be installed on Windows servers, but I personally haven't run into a Win server in many, many years. Okay, it is much older technology. It's really only if you've got a lot of applications that are using NetBIOS names. Windows no longer requires it. On a personal area network where you don't have any DNS servers, you don't have a router that's functioning as DNS, then you could use Link Local Multicast Name Resolution, LLMNR. This was introduced in Windows Vista. It's really a replacement to Broadcast Name Resolution, but you're never going to be using that in the domain environment. And really in most home environments, you're not using it because LLMNR would not give you name resolution for the internet. So you typically don't see it being done. The local resolution is also possible, and usually there is a combination. The local resolution is through cache primarily. A DNS client has a DNS client resolver cache. That cache contains the most recent names that I've sent out a query for, and then I've received an answer, whether it was an answer of yes, here's the address, or no, that host name's not found. You're going to cache both. That's kind of key to understand. And so the cache is actually looked at first. When a client tries to query server 1 or ping server 1, it looks in the client resolver cache to see if it has an IP address for server 1. If it does, and that entry in the cache is still valid, it hasn't expired, then it'll just use that entry. It'll use that information. If it does not, it'll query DNS. Once it gets an answer, it'll cache that answer for X amount of time based on the time to live, or TTL, of the record. And the same thing can happen for the NetBIOS cache. The other type of local resolution is the host and lmhost file for host names and NetBIOS names respectively, but these are just static text files that were really used significantly far back in the past, and they're primarily just there for kind of troubleshooting purposes in some cases. Okay. Finally, we would do a broadcast. So if I queried DNS and it didn't answer, I could send out a broadcast, which is essentially the equivalent of me yelling out and saying, hey, who's using this name? Or whoever has this name, give me your IP address, and you could potentially communicate that way. But that doesn't usually happen either. So typically what we have to worry about from this perspective is making sure that we've got the configuration set up correctly for a client to be able to query the appropriate DNS server. Let's take a look now at the configuration here, settings. Okay, of your Ethernet properties. You're going to see the IP addresses and whatnot, but you need to get into the adapter options, or we can go to the Network and Sharing Center here. If you go into Ethernet properties and details, at this point you are going to see your DNS server. Okay, IPv4 DNS server there is 192.168.1.204. I don't have a Win server, and that is very common. Okay, NetBIOS over TCP/IP is enabled, but no Win servers configured, so therefore it's almost as if it's disabled. If we get into the properties and go into TCP/IPv4, we see that we can obtain a DNS server automatically via DHCP. That is the norm. It's just in my current network setup, the IP addresses are actually being given out by a router that is not aware of the domain controller and the domain that I set up. So I go ahead and get a dynamic address, but set a static DNS. Okay. Not necessarily common in a lot of environments. Typically, we're just going to get both. All right. If you go into advanced settings, you do have some advanced DNS here. You can add multiple servers for availability purposes. So if the first is unavailable, it'll query the second, the third, and so on and so forth. If you have a significantly large infrastructure where multiple domain names are used. Let's say, I've got knockerball.com, but then there's companyabc.com, and then there's training.local over here. These are domain names that don't have anything to do with one another. It's not like a subdomain of another domain. Then it's in those situations where you might go in and you would add different suffixes. And I'm basically saying, okay, I want you to search that one first. I want you to search companyabc.com second. I want you to search localtraining.com third. You're giving it the order because you're telling the client when you send out a query for server 1, what's normally going to happen is what actually is going to go on is it's going to say server1.knockerball.com because that's the domain that I belong to. Okay, you're going in and telling the client, no, you actually want to ask for this name in multiple domains. That's key. Microsoft loves to come up with these scenarios where you have, you know, a large number of domains internally. It's a massive enterprise, and they want you to know how to deal with that. Well, this is how to deal with that. So that I don't know that I've ever had to do that in real life, but that has definitely been on an option for exam questions. And then down here, to register the connection in DNS automatically, that is a default setting. Okay. Over on advanced, this is also where you would configure the Win servers. If you were using that, this is where you can disable NetBIOS over TCP/IP if you don't have a need for it. All right, so let's then switch over real quick. Let's see the server side of this. So here's our DNS server, and I'm going to go and open up the DNS management utility. We've got our zone. This is called an Active Directory integrated primary zone. That just means the zone data is stored in Active Directory. I've got a record, a host record for my individual desktop. I've got a host record for my domain controller. I know earlier we had identified the service records that are used to locate the domain controllers. Okay, records are typically created here by default. And by default I mean through this process known as dynamic updates. So it's accepting dynamic updates, secure only, meaning only domain members. Okay, so if I have a new machine that joins, then that entry would be in the domain. Often help desk and support level, level 1 technicians have the ability to read this information. So you might be looking at the DNS database just to make sure that the appropriate records are there. That's something that potentially could happen. So you want to be able to get in and know how to do that. Also, if we go and we look at the properties of the server, we can see that this server is basically going to check what it's got, and then it's got some forwarders configured. And so anything that it doesn't have information on, basically anything outside of this knockerball.com zone, then it's going to query these public DNS servers, and it'll go find the answer for me. So if I query something outside of this, if I say resolve DNS hostname www.google.com, then it will resolve it for me. How did it find that answer? Well, it went out to the google.com name servers and found that answer. And we can plug in other answers or other names as well, and we'll get the exact same kind of thing, different addresses. And some of the addresses we're getting are IPv4 addresses. Some of the addresses we're getting here are IPv6. Okay, notice the difference, A record versus what I call the quad A, which is just AAAA. All right, so that's how we could resolve it. I'm going to switch back to the client. We've got the same things over on the client. Get back into PowerShell here. Get DNS client cache shows the DNS client cache. Okay, so that shows the one that I have communicated with. So if I were to ping www.google.com and get a response and then repeat that command, okay, now I've got my google.com. So I've cached that information. We've got the TTL, the time to live. How long is that information going to be retained? So every time I try to communicate with a remote system, then it's going to cache that information. Okay? Now, and it also caches success or failure. So notice there's a not exist here. Let's say I try to resolve DNS name like that, okay? And so I try to do that. It's going to go out and okay. Well, I assumed that wouldn't be registered. That apparently was a successful name, and there's the address. So if we made something up or we just mistyped and there wasn't a host like that, then I would receive information back that didn't exist. Okay, looks like that one exists, although that's the exact same one, which is a little bit strange. Okay, it's going to negatively cache. That was my only point. It's going to negatively cache, and if you need to clear the DNS client cache, you can do that simply by running that command. Okay, the first command there, resolve DNS name, is the equivalent of saying NSLOOKUP, which is another TCP/IP utility for www.google.com. Okay. That's essentially the equivalent there. Showing the DNS cache is the equivalent of the ipconfig display DNS. Okay. Although for some reason that didn't display it, but those commands are the equivalent. And then ipconfig flush DNS is going to be the flush. Okay, that's the same as the clear DNS client cache. Register DNS client. If you do that, it's going to force the registration of DNS records. That is the equivalent of ipconfig register DNS. So I'm just showing you the various commands because now there are PowerShell equivalents to the standard TCP/IP commands for you to be able to, to kind of hunt down name resolution. So, if you're having a problem with name resolution, the very first thing to check is the configuration. You can do so graphically. We can do that with the get DNS client server address command, and that'll show me the addresses on the interfaces. Your next step is to make sure that the server has the appropriate information. You can use NSLOOKUP or resolve DNS name for that. And then your third step would be, making sure that you don't have erroneous entries or old stuff in the cache. If you get the right server configured, the server's got the right information, and you're still not getting the communication you're supposed to have, then it could very likely be the cache. Since the vast majority of our communications use DNS, it's just this extra thing that we need to know about. We need to know how it works, and we need to know what some of the potential problems might be.